Hey everybody, this is Brian Smith with 321 Gang. Thanks again for joining us for our technical podcast, Change the Conversation, where we get together with various experts in the field of software and systems engineering and have a chat about what they do, why they do it, and why it's important in our industry. So we're real happy today to have Amit Talwar, right? Did I do it all right? From IBM here, otherwise known as Amit Talwar. And I think, Amit, you said that your name in Hindi means indestructible sword. Is that? That's awesome. I wish Brian Smith. No, it just doesn't go there. Maybe I think somebody told me that my name, might have been back in the days of blacksmiths. So maybe I made the swords for your family that were indestructible.
That's great.
Well, we'll cover that at a later time, Amit. So anyway, thanks so much for joining us. Amit has agreed to do a 5-part series with us around Automotive SPICE, otherwise known as ASPICE, because you're nothing if you don't have an acronym, right?
Exactly.
Right, and so I guess
real, right?
That's
Nothing's
exactly
real
right.
until there's an acronym.
It's not real, especially in our world. I think every industry has their share of acronyms, but we seem to have a lot.
Yes.
So we'll try. Let's make sure if we have some that we at least spell them out the first time for folks. Anyway, we're real excited. Amit is a solutions architect. I'm going to hopefully get this right. A solutions architect with the Watson IoT division of IBM, and within that, the continuous engineering team. Is that about right?
That is correct. Yeah.
And yeah, so we're going to be talking about ASPICE, and I think the background here, right, Amit, is that the automotive industry, like many other industries, is getting super complex, trying to parse together software, firmware, hardware. Driverless cars, all these new features and functionalities. People don't buy cars anymore for the horsepower, or they buy them.
All about the functionality that the car can provide for them, whether that's entertainment systems, infotainment systems, right? Autonomous driving capabilities, right? I want to know if I'm going to change my lane, am I going to hit something? I don't have to look in my blind spot, right? Those are things that.
Done that.
Yeah.
Did that a couple of years ago. Yeah, smashed into a Mercedes van. That was sad.
Yeah.
And he was in my blind spot. That's exactly what happened. So it was my fault. It's a different story. So so let's so then I guess that's the background, and you would add to that, I think, supply chain, because the automotive industry has more complexities around technology because they often outsource different parts of the car, right?
Yeah, the supplier community in the automotive industry, the OEMs, everything down tier 1, tier 2, tier 3 goes down the line, and the importance of having some type of way of auditing those suppliers from an OEM perspective about the software and the systems that they're providing to them, because at the end of the day, the OEM is the one that's responsible. And these systems that they're providing are many times safety critical systems, where you're looking at the safety of the passengers in the car, drivers of the car. You have to ensure that car is going to perform, that system is going to perform as it's intended to. And if it fails, that there's
no room for error, right?
Yeah, there's no room for error, because that means damage or a life loss.
Recalls.
Yeah, exactly.
Right? Recalls based on software, are still expensive recalls. And
you look at GM's airbag issue, the supplier in that was Takata, right? That drove a huge change in the way that the OEMs and the suppliers had to change their business models and how they're actually going to develop and deliver software.
So, really absolutely critical. Lives are on the line, and that's those are the sort of industries that we work in: automotive, aerospace. Lives are on the line, and so there's no room for error. So I guess what we're going to do today, continuing with this conversation, is really just provide an overview of what is ASPICE and why it's important to the automotive industry. And I think we've touched upon some of the reasons that it's important. But maybe we could dive into more specifically what problems ASPICE is trying to solve. What is that? Is that a good question?
So that's a good question. I mean, so ASPICE in itself is based off of the IEC 15504 standard. It's really meant to be a framework for OEMs to assess their suppliers for those that are actually delivering software and systems to them.
If you look at it's not an assessment necessarily of the OEM, but I'm sure you can do that too. But it's a way for them to then
be able to assess their suppliers who are actually supplying them with the software.
I see.
If you look at the industry today, every supplier for OEM is being, they can't win business from those OEMs unless they have a capability level 2 or 3. That's being required, just being able to bid.
Just to bid.
Programs. Just be able to bid on programs.
Okay, so let's back up a second. So what is the range? Is it 1 through 5?
It's 1 through 5.
Okay, and 1 is the highest.
No, 1 is the lowest.
One is the lowest.
One's the lowest. Yeah, ASPICE 5 is the highest level of maturity.
Oh, so we're going back to like CMM and CMMI type of.
It's a similar type of rating, right?
Got it.
ASPICE is meant to be a scaled down version of the IEC 15504. Scaled down version of work products available.
Right.
But it really is. It's ensuring some key aspects around the engineering process groups, whether developing systems or software for the system.
Now, does it touch all parts of engineering in a car, or did it grow out of one area and it's being applied to others? Who within this automotive world is most affected by using SPICE?
Yeah, so there are SPICE. SPICE does handle supply chain also. Mostly focused where we see it, the need for it is around developing the software systems that organizations are developing, and the overall systems engineering that they need to do on those systems. That's where we see the most amount of effect for changing the way that organizations are doing their work.
Got it. So as a supplier, then, if it's you mentioned infotainment systems earlier. So I'm an infotainment supplier, and that's more a software-centric system. I mean, obviously it has to display on a monitor, and there has to be controls for it and everything like that. But that kind of system would lend itself to an OEM wanting their supplier to have a certain capability, maturity level before they offered that.
Exactly, and it's not just infotainment systems. It's pretty much every system in a car today. If you look at a car, every car's got over 100, maybe even more, hundreds of computers, little small ECUs in them driving every aspect of it. And all those ECUs are intertwined together. So you have to understand there's a big integration issue from the OEM standpoint and making sure that those systems that they're getting from different suppliers, when they integrate them, that we need to make sure that they're going to do what they're going to do and not going to affect any other system. Yeah.
I was going to ask you about that, but that's probably a topic that we'll cover in a future podcast, right?
Yeah.
All right. Well, then, so are there other ways that ASPICE affects the OEM supplier community? Are there?
I mean, so far, what I've seen in the industry, I've been in the auto industry for 15 years prior to becoming a solution architect here at IBM. Systems and software engineering has been just growing exponentially as the amount of software that you're seeing in cars is just expanding.
It's amazing.
It's amazing, yeah. It's hundreds of thousands to millions lines of code in every vehicle today. That need is driving the way, it's changing the way that the suppliers need to be able to deliver their work.
Right.
They need to ensure that not only are they meeting the requirements they got from the customer, but they need to be audited on. The customer, their OEMs that supply them with certain requirements of these systems, they need to be able to show that they've actually implemented those and they're aligned to the requirements that they have internally for the systems that they're building.
Now, back in the day, I remember CMM and CMMI were more about building a process and being able to demonstrate that you're following the process. But there was some folks who were a little critical about it because it didn't focus a lot on continuous improvement once that process was in place. Does ASPICE address that?
It does. It does. Yeah.
Okay.
So there are things around there about ensuring consistency of what you're actually delivering, right?
Mm-hmm.
Making sure that there is a way, and that's actually the different levels also, right? So as you progress in levels, right? Level 1 is establishing. Level 2 is being able to manage it. You know, there's multiple different levels.
So the higher levels are probably where you're actually.
Yeah, it's the level of the maturity, right?
Mm-hmm.
Yeah, exactly.
Okay, well that makes sense to me. And so organizations that are looking to adopt ASPICE, what do they struggle with? How do they start? Or if they've started, I guess a lot have started, a lot of the clients that you're working with, but they probably struggle to move up the capability ladder, right?
Yeah, so I've worked with just recently 4 or 5 different suppliers, and a lot of the struggles that they deal with are very similar. Right? They'll go through an ASPICE assessment to assess where they're at today,
right.
And most of them are ranked around a 0 or a 1, and they're trying to get to a level 2 or level 3.
Sure.
And a lot of that is around just some base practices around establishing traceability between the very different artifacts, right? The requirements that they get from their OEMs, down to the system requirements that they're developing and the software requirements, making sure that there's traceability to the tester, ensuring that they've actually validated that they've met those requirements and implemented them correctly, and having test results that show that and prove it. That is just one key aspect that we see many organizations struggle with. Some other organizations struggle with the actual ability to allocate those requirements to the architecture that they're developing and showing the dynamic behavior of that architecture, their system architecture.
So it strikes me, Amit, that these organizations have probably had to do those things in the past, but it was all manual, or it was highly manual, and and they tried to automate some of it. So I think one of the things that when you talk about being able to link those things, you're talking about automation and how to do that in a way.
Yeah.
I mean, obviously you have to train people to remember, right? Change is hard. Changing the way people do their work and record their work and plan their work and things like that is hard. But once you get that in place, then getting that into a tool is important so that you can then automate some of the things you're talking about.
Exactly. Right? I mean, whether you're doing CMMI, ASPICE, any other type of standard that you're trying to comply to, you can definitely do it with pen and paper. I mean, that's how we used to do things back in the day.
Sure.
Before the computers, right? You can do that. You can do it with spreadsheets. You can do it with documents. But you want to let an efficient way and something that's live, right? So you can ensure when something does change, you are aware of that change. Or you have the ability to, and others are aware. That you have the ability to analyze the impact of a change prior to actually making the change, right? And lots of organizations struggle with that. It takes a lot of effort and cost to be able to do that, and a lot of times they miss things, and then they pay for it down the line when they have things like when they have like recalls in production. And they're trying to avoid them.
Like any software system that we've worked with, right? If you find things late in the life cycle, it's just that much more painful and costly to fix up, and in the automotive industry, maybe even more so because of all the things you just mentioned. So I think that's what we're going to get into in some of our future episodes here, but can you give us a brief overview of what tools from IBM are involved in helping automate some of these activities?
Yeah, I mean, so if you look at the ASPICE process reference model, most areas where we focus with automotive organizations on the supplier community is on the systems engineering process group and the software engineering process group. There are some other supporting process groups that manage how they actually govern their change management, how they govern their problem management, how they identify anomalies or issues or defects, bugs that they find in their software, how they actually kind of mitigate those.
Right.
how they actually get those to resolution.
Mm-hmm.
So those are areas where we're going to focus on.
All right.
If you look at those areas, I mean, our continuous engineering platform really is covers a lot of the base practices around traceability. Each one of those process groups has base practices around traceability. I think
Right.
there's like 13 or 14 base practices around that. And
Okay.
our continuous engineering platform is an integrated solution. So we have in the different domains, whether it's in requirements, in modeling, in tests, in source code management, and change management,
Mm-hmm.
all those areas are integrated tightly, and establishing bidirectional traceability is easy
Mm-hmm.
to do, and it's also utilizing it, you can use that information to, query on and understand
Okay.
the relationships between. If you look at that, if we look at those base practices in those areas, if we look at, sys.2 and sys.3, that's covering system requirements, the architecture,
Mm-hmm.
down to software requirements and architecture, looking at the left and right side of the V. I mean, we go down the left side. That type of
And connect to the right
relationship,
side, right?
yeah,
Your
yeah, exactly.
requirements to tests.
Yep. And those relationships are available on our platform. We set up, out of
Mm-hmm.
the box relationships to be able to show those relationships between those different domains.
Right.
In our Doors Next Generation product, a solution is our requirements management solution, and it really handles that left side of the V, being able to relate your stakeholder requirements to your system requirements down to your software requirements, and even lower levels as needed.
Right.
We can utilize Rhapsody as our modeling tool to be able to develop, how we're allocating those system requirements into our architecture, how we're allocating our software requirements into our software architecture, and our detailed
So there's a
design.
way to link your model-based systems engineering activities into your ASPICE activities using these tools.
Yeah. I mean, part of ASPICE, one of the base practices is being able to allocate requirements to your system model, right? So that is not just allocating them to them, but actually setting up bidirectional traceability between the model and the requirements that you're modeling.
Mm-hmm. So changes to one side can affect the other, and suspect links or whatever they're called, and things of that nature.
As long as if there's a change in requirement, the system engineer, can update his model. He understands what the change is, and making sure that his model is reflecting the change in requirement.
I was going to say, I mean, that's one of the things I was thinking about earlier. Is even though this it's similar to the clients I work with that are have grown their agile capabilities, right? It's coming from a software side, and maybe more IT. We do engineering as well, but and then other parts of the organization start to see the value and try to apply it in those places. So what I'm hearing, I think, is that a similar growth path is occurring where software teams have traditionally been the ones to adopt ASPICE first, and then systems engineers are getting pulled in because it's all related, and it's important that all of those things are traceable across these different domains. So, and these tools can help them communicate better. Yeah.
It helps them establish that bidirectional traceability, which is required for ASPICE.
Nice. So
I would say getting back to the other solution areas, our change in configuration management tool called Team Concert really handles some of the supporting processes around having change management around those areas. So change management to your requirement, change management of your code, and then our whole right side of the V, making sure that everything from the software requirements all the way up system requirements, we have validation of those, right? We're making sure that we're doing our unit testing, we've related our unit tests and our results of those unit tests to the detailed design of the software, our integration tests, and those results to our software architecture. As we go up, trying to make sure that the system integration is related back to those system requirements, and ensuring that we've met those requirements and verified them.
Well, I mean, in the last 3 minutes, you have created. It's obvious why we've created a 5-part series here, because there's a whole lot to cover in what you've just described, and being able to link requirements and tests, models to requirements. It seems to be a lot requirements driven here, and then you've got the pieces that sort of revolve around requirements, which makes sense to me. And so we're going to move into those things. I think the next, I'm going to cheat here and look at my notes. We're going to talk a little bit and demonstrate how to establish bidirectional traceability in a consistent way using some of these tools in our next episode.
Yeah. So regardless of what process group you're trying to meet in ASPICE, bidirectional traceability is required through all of them, and that's what we're going to focus on. And that's our sweet spot around our platform. We're able to establish it, but then we also do awesome things with it, like be able to understand the impact because we have these different assets and we know the relationships between them. We can do things like query on them. We can understand the impact of change. Right? And those are things that lots of organizations do struggle with.
Well, I'm really looking forward to having a look at that. So before we just wrap up here, Amit, is there anything else you want to finish with?
No, thank you for the opportunity to have this podcast.
Yeah, absolutely. So just want to remind people that if you want to contact the Indestructible Sword, his contact information is at the bottom of this podcast window, as well as links to other resources at 321 Gang and at IBM. And as we record these additional podcasts, those links will be down there as well. Amit, thanks so much for joining us, and we look forward to getting together with you again real soon.
Thank you so much, Brian.
All right, take care.